Welcome friends to the Agrawal Structural Academy. First we learn whether the frame is a sway or a non-sway. For that there is 4 points. The first is support condition. Second one is MI of column. Third one is the height of column, and fourth one is the loading condition. Now suppose take this example here. Now suppose this is having this same length, same height of this column. I is the same, okay, but here what support condition is different, so this is called as a sway frame. Now suppose take example another. Here both having the column having the same I, same support condition, but having the different height. So this also called as a sway frame. Take the third condition. Now suppose this is the column having the same height, having the same support condition, but this is I, this is 2I and this is I. So also called as this type of frame is called as the sway. And suppose having the same support condition, same height, same I, but here loading is unsymmetric. So this type of frame also is called as the sway. Now we take one example on here. Now this is example is of a sway analysis because having the different height. Load is symmetric, this I is same but having the different I. So in the case of the sway analysis, there is a two step. First is called as a non-sway step and second is called a sway analysis step. In the case of non-sway analysis, we have to find the sway force, and by using this sway force find out the sway analysis. Then the step is to find the Ki, it is kinematic indeterminacy, that is a 2. It is a support A is a fixed, support D is a fixed, so this 2 is the possible. So that is IB and IC. It means that is the here you have to balance the two supports. Now first clamp each the column and find the fixed end moment. So here clamp AB, clamp BC and clamp CD. So here what here, that is M bar AB is equal to this M bar BA is equal to the 0 because of no load. Then again this M bar CD is equal to M bar DC is equal to the 0. Then this M bar BC is equal to minus WAB, so that is minus 25 kN, and M bar CB is equal to the plus 25 kN. Now first here assume that there is some imaginary restraining forces acting on this frame in any direction, from here also or here also, and do the non-sway analysis. So here the next step is the distribution factor for this frame. That only we have to, this is the distribution factor 0 and 0. So we have to find out this B to A and B to C and C to B and C to D. So here these are the joints B and C. So BA, BC. So here B to A. B to A is a fixed end, so that is why is I by L. Then B to C, again this is a fixed end, that is the I by L. Then C to B, again that is the I by L, and C to D again the I by L. So these are the distribution factors 0.5, 0.5, 0.43 and 0.57. So now put all this value into our MDM table. Now this is the table of MDM. M bar AB, M bar B is 0, M bar CD, M bar DC is 0. Now here is a BA is 0 and BC minus 25. So here we have to balance the support. No need to balance support A and D because of the fixed end. Now take the joint C. We know sigma MB, that is equal to MBA plus MBC. So 0 minus 25. So this is minus 25. So this is the unbalanced moment. So we have to balance this support. So balance moment will be equal to opposite in nature and same in the magnitude. But this is applied at this joint B according to this distribution factor BA, that is 0.5 into 25, and BC is 0.5 into the 25. So this becomes here the 12.5 and 12.5. In the same way, take the joint D here. So sigma MD, joint C, sigma MC is equal to MCB plus MCD. So again there is 25 plus 0, so this becomes a 25. So this is called as a unbalanced moment. So your balancing moment is equal to minus 25 kilonewton meter, which is applied at the joint C, but according to this distribution factor, so CD is equal to 0.43 into minus 25, CB and CD is equal to 0.57 into minus 25. So this is the minus 10.75 and minus 14.25. So here minus 10.75 and minus 14.25. So now here this is a fixed end. So transfer here, the carryover is a half here, carryover is half here, then half is to here and half is to here. So now do this process continuous till this value after the balance is near about the 0.1. Okay. So this is the final result here. This is the balance. This is the balance, and then transfer half to here, half to here, half to here. Again this is a balance. Again transfer half here, half here, half here, and half here. Again this is a balance to here, balance to here. Then again carry over here, carry over here, carry over and carry over. Now this is unbalanced movement. Again this is to balance. This is 0.139, 0.39, and this is a balance. But this value are the still larger, 0.14, 0.19. So again we have to transfer this movement, carry over here, here, and here, and to support A. Okay. Now again this is the unbalanced movement and this is unbalanced movement. So again the balance. So this value are the quite small. So when the value is less than 0.1, in that stage we can stop here. Always stop when the support is to balance. So this stage is a balancing stopping stage here. So this total from 0 to here, this 7.99, from this 0 to 16.031, and this is minus 16.031. From here is 18.8, then from here is 0 to 0.44, so that is minus 18.8. Then last is 0 to 0.95, this is minus 0.38. Then we have to draw the three-point diagram of the column. Then draw the free body diagram of this column. Suppose this column is AB, this is a fix, and this is a B point. Now here this is a plus, it means clockwise. So at the A, 7.99. Here also this is a plus, 16.03. This is support A and this is support B. Now here is a reaction, so this is clockwise, so that should be the, assume this direction HA in this way. Now here we have to take the sigma MB is equal to 0. This is the free body diagram of the column AB. This is the moment at the B, this is the moment at the A. These values are the positive, that is why we have taken as a clockwise, and this direction is the assumed direction. So take the moment at about this B, so this clockwise is a plus. Then this also clockwise is a plus, and this height is a 4 meter. So HA into the 4, that is a minus. So minus HA into the 4, that is equal to 0. So HA into the 4 is equal to 16.031 plus 7.99. So HA is equal to 16.031 plus 7.99 divided by 4, and that is equal to 6.0 kilometer. Now this value is a positive, it means what we have assumed direction is correct. Otherwise you have to change the direction. Now in the same way we have to take the column CD. This is the point D and this is a C. Now here these moments are both are the minus, means both are the anti-clockwise. So at the D is 9.38 and here is a 18.80. Now here we have to take the, this height is 3 meter. Now here we have to assume the direction of the HD. This point is D. So suppose we assume here in this way HD. So take the MC is equal to the 0. So this moment is anti-clockwise. So take as minus 18.8, the minus 9.38, and this force is a clockwise. So plus HD into the 3 is equal to 0. So HD into 3 is equal to 18.80 plus 9.38. So HD is equal to 18.80 plus 9.38 divided by 3. So that value is HD is equal to 9.39 kilonewton. Now the next step is to find the restraining force. Initially in this frame we have assumed that here or here some restraining force is acting, that is why we have did this here, the non-SW analysis. So our aim is to find this, the restraining force. So now this HD here 9.39, then this HA in this direction, it is 6, A, B, C and D. Now here we have to assume that any direction of the restraining force, this or this. If this value is plus, the direction is correct, otherwise we have to change the directions. So we assume the restraining force is acting in this way. Suppose this is R. So here we have to take the sigma h is equal to 0. So what is here? Consider this side as positive and this direction as the negative. Now here this r is a plus, then this is a 6 is plus and this is minus 9.39 is equal to 0. Summation of sigma h. So r is equal to 9.39 minus 6, that is equal to 3.36. 3.39. Okay. Now the sway force is always opposite to the restraining force. So here next step is to do the sway analysis. So in this case you have to remove all the loads and apply only the sway force. So this is direction of the restraining force. Your sway force is opposite to this direction. So this is our frame. This is A, B, C, D. Now apply this the sway force S, that is equal to 3.39 kN. This height is 4 meter. This height is. So this sway force try to push this towards the left. So deflection of this column is like this, in this way. So if they push towards the left, here this type of moments are produced here. That is the sinking moment, that is 6 EI delta by L square here also, and here also the 6 EI delta by L square. Here also 6 EI delta by L square. Here also 6 EI delta by L square also. Now again we have to here find the fixed end moments for the span AB, BA and this BC. Now fixed end moment. So M bar AB, that is equal to here. Now this M bar AB, BC moment is produces the clockwise. So take as plus 6 EI delta by L square. Now here, before that, we have to assume any value of EI delta between 20 to 80 generally. So here we are assuming the value of EI delta as the 50. So here put this value of EI delta here. Now here also I is equal to I for this span AB. If there is a 2I, so put here the I is equal to 2I. But here in this case I is equal to I, so put here 6 into EI delta is 50 divided by L is equal to the 4 meter. So the 4 square. So this is nothing but 18.75. Then M bar BA is equal to, again M bar BA, this is a clockwise, so always both sides are the same. 6 EI delta by L square is equal to 6 into 50 divided by 4 square, so that is 18.75. Now for span BC, there is no load. That is why this M bar BC is equal to M bar CB is equal to the 0. Now the span CD. Here L is equal to 3 meter and I is equal to I. Now from this here, both are the here movements are produced the clockwise 6 EI delta and 6 EI delta. So M bar CD is equal to plus 6 EI delta by L square. Now here I is equal to I. In the case anywhere, suppose it is 2I, 3I. So put here 2I or 3I and then put the value of EI delta as 50. So 6 into here 50 divided by 3 square. So this value is 13.33. Then M bar DC is equal to 6 EI delta by L square is equal to 6 into 50 divided by 3 square. So this value is 13.33 kilonewton. Now put all this value into our again the table. This is the table. So here is 18.75, 18.75. Here is 0, 0, 33.33 and 33.33. Now again perform the same process. That take the joint B is here. So sigma MB is equal to MBA plus MBC. So that is 18.75 plus 0. So that is 18.75. So this is the unbalanced moment. So you have to apply here the balanced moment. That is minus 18.75. But according to this distribution factor, BA is equal to 0.5 into minus 18.75 and BC is equal to 0.5 into minus 18.75. So these values are the minus 9.375 minus 9.375. Then take joint C, sigma MC is equal to MCB plus CD. So here 0 plus 33.33. So this value is 33.33. So this is our unbalanced moment. So apply here the balancing moment. It is minus 33.33. But according to this distribution factors. So CB is equal to 0.43 into minus 33.33 and CD is equal to 0.57 into minus 33. So these values are the minus 14.33 and minus 18.99. So perform now. Balance this, then the carry over here, then carry over here, carry over here, carry over here, and this do the same procedure till this balancing value should be the 0.1. So this is the final table. Now this is the balance stage. Then again this carry over here, carry over here, carry over here. Then this is carry over here. Again this is to balance, and balance. Then again carry over. In here this carry over and this carry over. The final values are the 15.69, 12.62, minus 12.62, minus 16.07, 16.07 and 24.72. Now again here, this is the table that is final. The final moments are the 15.69, 12.69, 12.62, 16.07 and this. Again you have to consider the columns here. So these values are the plus, it means are the clockwise. That is 15.69 and here at 12.62. Now this is a clockwise. So we have to assume the direction of SD anti-clockwise. This height is a 4 meter. So this joint is a B and this joint is the A. So sigma MB is equal to 0 here. So 12.62 is plus, this is a plus and this is minus 4 into HD is equal to 0. So here find this HD is equal to 7.08. Then the same way consider again this column CD, this C, the joint is D. Now here again these both moments are the positive because of clockwise. Apply here. So 24.72 and here 16.07. Now this is a clockwise, this is a clockwise. So again we have to assume this direction H, this is HA. Now this is HD. So sigma MC is equal to 0. This is C and this is C. So 16.07 plus 24.72 minus 3 into HD is equal to 0. So HD is equal to 13.60 kilonewton. Now again we have to find the sway force which is to be developed. Now here in this case we have assumed that EI delta value is the 50. E is assumed value. So from this we have to find out how much due to these two moments 18.75 and these two moments, how much the sway force is the developed. So find this sway force. So again here we have to take the sigma H is equal to 0. Again draw this frame. Now this is our HA, this is our HD. So HA is the 7.08 and HD is 13.6. So again consider this as positive, this as the negative. So our aim is to how much a sway force is developed due to this application of this the moments, this 13. So here 7.0, assume this is the sway force is developed. So this direction is positive 7.08, then plus 13.60, and this is minus s is equal to 0. So this s is equal to 20.68. Actually, the sway force that we require is 3.39. This 3.39, but what we have applied that EI delta 50 that develop the 20.68. So here we have to find the correction factor. So that is equal to this 3.39 divided by the 20.68. Now this is also in the direction, this is also in this direction, so both are negative. So that is why this value is positive, that is 0.16. Now this is multiplied to here. These factors multiply to these moments to be here. These values. So our final table is like this. This is the AB, BA, BC, CB, and the CD and DA. These are the non-sway moments which are taken from here. That is 7.99 AB, BA, BC, CB, CD, and DC. And the sway moments that we have taken from this here 15.69. These are all the moments. So multiply this sway moment by the correction factor. So 15.69 multiplied by 0.16, this correction factor. We have the ratio of this, the sway force actually divided by the sway force developed, that is 0.16. So multiply the 0.16 and then algebraic sum of these moments, algebraic sum of these moments, algebraic sum of moments. So these are the our final moments. Thank you.